Alright, so for question 4, it says, is the relationship shown in the data line linear? If so, model the data with an equation. So this time we're going to be given a table versus like a graph or just 2 points. We're still kind of using the idea of the slope formula. So we're kind of still using that y2 minus y1 over x2 minus x1. Only with a table, it does make it a little easier for you guys to kind of visualize it. So if we're going across, these two would be a point. So these two would be a point, these two would be a point, and these two would be a point. So we can choose whichever we want to be point 1 and whichever we want to be point 2. So I can go towards, go up. So I'm going to start off with 6, and I'm going to subtract it by 4. If I go up that way, then I also have to go up with the x's. So I'm going to have 3 minus, this is a negative 1. 6 minus 4 gives me a positive 2. 2 negatives, so I'm going to become a positive. 3 plus 1 gives me a 4. And if I simplify that, I can divide the top by 2, and I can divide the bottom by 2. 2 divided by 2 gives me a 1. 2 goes into 4 2 times. I can't simplify it anymore, so I know that's going to be my slope. If I want it to be linear, then every time I do this, my answer should be 1/2. So then let's do this a couple of more times. So we're going to use 5, 7 as our starting point, and we're going to go towards the 6. So we're going to do 7 minus 6 divided by, going up, 5 minus 3. 7 minus 6 gives me that 1. 5 minus 3 gives me that 2. And so far I do have that pattern of getting 1/2. And I want to do it one more time just to make sure 100% that it is true. So we're going to do 10 minus 7 over 11 minus 5. 11 minus 5. 10 minus 7 gives me a 3. 11 minus 5 gives me a 6. I need to find what both of them have in common, so I'm going to divide the top by 3 and the bottom by 3. 3 divided by 3 gives me a 1. 3 goes into 6 2 times. And again, 1/2. I do know that this will work. Let me grab another sheet. So as you guys are copying that down, I can grab another board. So the problem says, if it is linear, I do need to write it as an equation. So I'm going to move this guy over. I'm going to put a new board up. So this time, I can pick any equation that I want, but since I have a whole bunch of points, and I do have my slope, it kind of makes sense for me to use a point slope form. So the point slope form is going to be that y minus y1 equals mx minus x1. Where, like I've said before, my y, my equal sign, and my parentheses with that x don't change. My slope for each one of these was 1/2, so I'm going to plug that in. I will use a different color. And I can pick any one of these problems. So if you guys are doing that, I can have 4 potential answers. So, eeny, meeny, miny, mo, let's do 5/7. So my y, I'm going to do the opposite of what I see. So since I have a +7, I'm going to have a -7 here. And since I have a +5, I'm going to have a negative. And since you have a +5 over here, you're going to have a -5. So again, we go back to the beginning. We're trying to find if every slope is going to give us the same thing. So if I take the slope form and I do it for each pair, I should get the same thing if it's linear. So if I'm going up, 6 minus 4 is 2. 3 plus 1 is 4, so that does give me a half. 7 minus 6 is 1. 5 minus 3 is 2, so again, 1/2. We have to do it for all, or at least 3 if you end up having more points, just to make sure that you do see that pattern, because sometimes you might get it the same in one, the same in the second one, but the third ends up being something different. But we do it that last time. 10 minus 7 is 3. 11 minus 5 is 6. Divide top and bottom by 3, and we get that 1/2. When we do put it into our point slope form, we can choose any one of these. So it could be -1, 4, 3, 6, 5, 7, or 11 and 10. So you have 4 possible answers to get. It doesn't matter which one you picked. So like for ours, we ended up picking 5 and 7. So we end up putting our slope first. Our 5 is going to be negative, and our 7 is going to be negative as well, so then you'll get this as your answer.